Is for worksheet 1-3 for Discover Algebra Part 1. Geometry Part 1. So I'm going to go ahead and zoom out so that you can see all the answers and kind of check yourself. Ooh, I zoomed out way too much. There we go. So if I'll let you see the top, pause, grade yourself, come back, I'll scroll down, okay? All right, so that is how we, the answers to this worksheet. Let's go ahead and go through how I did that, okay? So in this first one, you were supposed to draw on a piece of graph paper a circle with a radius of 3. So on my graph paper, I'm going to draw a circle. My draw function must not be on. I'm going to draw a circle. Does it have to be perfect? No, but there are a few things I can do that did not turn out right. To help myself, if I have a radius of 3, there's a radius of 3. I can also have a radius of 3 this way, a radius of 3 this way, and a radius of 3 this way. So I know my circle will have to go through these points because a radius goes all the way to the outside edge of the circle. So let me see if I can freehand a circle. Yeah, I'm not very good at it. I usually have to use my circle tools, but I know a way I can do it. Oh, maybe not. Oh yeah, because I'm on the graph paper. Never mind. Just do your best. All right, that's pretty close. All right, and then it tells us to find the perimeter and the area of this circle. So remember, perimeter is 2 pi r, and area is pi r squared. Take that 2, put it on top, okay? So if I put in my numbers, and when I found my answers on the worksheet, I used the pi button on the calculator. Today I'm going to use, this time when I do it, I'm going to actually put 3.14 in. So you can see the slight difference we sometimes get in our calculations when we use 3.14 instead of the pi. And in this one, it's 18.84. If I bring up the last worksheet, you'll see it's 85.85 at the end, okay? So just a little bit of difference whenever you use 3.14 instead. All right, for my area, I'm going to use 3.14 so you can kind of see that difference and know that you just got to be close to my answer because a lot of it depends on which number you use for pi, what your answer is going to be. And if you just use 3.14 instead of the pi key, you're going to get 28.26 inches squared. All right. Which, if you look at our worksheet, we got 27 instead of 26. It's just slightly higher when you use that pi key. All right, so the next one, we're going to draw one with a diameter of 10. Okay, so a diameter of 10, remember the diameter goes the whole way across. So if I start here, 1, 2, ooh, this isn't going to work. I didn't leave myself enough room, did I? All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I have it over too much. I want to be at 5. 1, 2, 3, 4, 5. There's my center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see, I'm kind of figuring out what those radiuses are. I've already figured out that my radius is 5, which is half of my diameter. So there's my circle. My diameter is 10 centimeters, and I got to find that perimeter in that area. So the perimeter is 2 pi r, which is 2 times, and we're going to do 3.14 for this one, so you can see the slight variation. And my radius is 5, so it's going to be times 5. So basically it's 10 times 3.14, which is going to be 31.4 centimeters. And for the area, we do pi r squared, which is that 3.14 times 5 squared, which is 25. And we should get a slightly different answer, slightly lower answer than the one on the other sheet. It's going to be 78.5 centimeters squared. All right, now to do our shaded regions. Okay, so in this one, I'm just trying to find the blue area. So let's just find the big shape, because it's just going to be big minus small. Okay, so my big shape is 8 times 8, which is 64. And my small shape is 6 times 3, which is 18. And if I subtract those, I get 46 inches squared. It's still area, so it's still squared. In this one, it's a little bit different, but I know that this side has to be this side. Now, a circle can only belong inside a square because it has to be perfectly symmetrical. And we can see that because if I were to write a diameter this way, we could assume that that's the same as the diameter in this direction. So it would also have to be 10 centimeters, which means that corresponds with this side, which is 10 centimeters. So the big shape, the square, would be 10 times 10, which is 100. But the circle, the area of that is pi r squared. So it's actually, and this time I'm going to do 3.14 so you can see the difference, times 5 would be the radius. So radius squared would be 25. And if I put that into my calculator, which I'm going to do real quick, using 3.14 instead of pi, ooh, I forgot parentheses. Can't forget those parentheses. I wanted to actually do the area first, which most calculators will do because that's multiplication, but just to be on the safe side. All right, and that's going to give me 21.5 instead of 21.46. So in this time I actually got slightly higher, and that's centimeters squared, probably because of rounding. All right. The last one is where we're going to graph the vertices of this polygon. There's many different ways that you could have graphed this. I'm going to do one way, but you don't have to do it that way. All right. I'm just going to look in the first quadrant because none of my values are negative. If I remember correctly, I have to be able to do 10 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8. So let's go ahead and graph these points. First one is 1, 1, and the second one is 10, 1. So 10, 1. Next we have 10, 8. Then we have 7, 8. So back 3. 10, 9, 8, 7, 8. So there's 7, 8. Then we have 7, 5. So this is 7. 1, 2, 3, 4, 5. Kind of interesting, that shape. And then we have 4, 5. So 1, 2, 3, 4, and then 5. 4 and 5, and then 4 and 8. So all the way up there. And 1 and 8. So there's different ways you could have done this. I'm going to do this way now. This is not the way that I did it before, but I'm going to do it this way now. But do it slightly different than the way that I did it for the answer key. And I'm going to show you something about that, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this side is 9 units. This side is 1, 2, 3, 4, 5, 6, 7 units. Then this is 3 units, 3 units, 3 units, 3 units, 3 units, and this side is also going to be 7. All right, so if I want to find the perimeter of this shape, I just add all those values up. 1, 2, 3, 4, 5 times 3 is 15. Then I have 2 7s, which is 14, and a 9. All right, so if I add those two, I get 29 plus 9. That's going to be 38 as my perimeter. Let's go back to the other sheet. Ah, look, I'm in the vicinity. I'm close to the same perimeter. Last time I made like these little triangles when I connected my dots. So yours might be different. Okay, might be different. And you might be saying, so the first time I did it with triangles, because triangles have very clear vertices, but this also, these points are vertices, okay? So you should be in the same area as me, even if you draw a different shape out of it, but it's going to be a little different. Now to find the area, they want us to use triangles. So you know what, I should use a different color. So I'm going to make a triangle here. I'm going to triangle here. I'm going to make a triangle here. And a triangle here. And 2 big triangles. So triangle number 1 is going to be 3 by 3 divided by 2. That's how you find the area of a triangle. So it's going to be 9 divided by 2, which is 4.5. The area of the second triangle here is also going to be 3 times 3, which is 9 divided by 2. So it's also going to be 4.5. Same thing with this one. It's going to be 9 divided by 2, which is 4.5. And same thing with this one. It's also going to be 4.5. Now this one is going to be 1, 2, 3, 4 by 9. So 4 times 9 divided by 2. This is going to be 36 divided by 2, which is 15, 16, 17, 18. And guess what? Oh, this should be 5. This one is also going to be the same thing, okay? It's also 9 by 4. 1, 2, 3, 4. So it's also going to be 18. Now let's add up all my areas. So my area total, T for total, is going to be 4.5 times, how many of them do I have? I'm going to turn my repetitive addition into multiplication. 1, 2, 3, 4. So 4 times 4.5. Plus 2 times the 18. I have 2 18s. All right, and 4 times 4.5. It's going to be 18. Isn't that clever? And 2 times 18 is going to be 36. Add the 18. It's going to be 54. So let's see, in the other shape I was able to make out of my polygon, what did I get? I got 54, okay? So in both, you may get a slightly different perimeter as me if you used a different shape, if you made a different shape out of your lines, but you're going to get the same area as me. No matter what you do, you should get 54 units squared, and that's pretty true with polygons. That's always going to be true of polygons. We did that experiment where we used the string and we kept making different shapes and the perimeter kept changing, but the area was always the same. So it doesn't matter. I can make different shapes out of those points and the perimeter will keep changing, but not that area. Okay? Awesome job. So come back and visit me if you need any more help. See the next video, and I'll see you guys in class. Bye.